G'day chemists. Today we're going to talk about ions. Now, by the end of this, what I'd like you to be able to understand is, or predict even, is how an ion is formed, as well as what the charge is going to be. And we can predict the charge from the valency. And this is all based on the position or location of the periodic table. This is your vocabulary, so if you can just get you to pause the video, write this down, and you'll have to refer back to as we move through the lesson. So, valency. Valency is determined by the number of electrons in the outer shell, and we call this the valence shell, right? So, the valence is different to the charge, but they're related very closely. So, for example, if beryllium needs to lose 2 electrons to move to a stable octet. Now, octet isn't necessarily true. For example, beryllium, if it loses 2 electrons, it will have a doublet. It'll just have 2 electrons in its outer shell because it'll move to the same electron configuration as helium. And by being the same electron configuration as helium, we can say that it's stable. So in other words, it's actually simpler to say that they will move to their closest noble gas. So if beryllium wants to move to its closest noble gas configuration, electron configuration, it needs to lose 2 electrons. So if it loses those 2 electrons, it will have a charge of 2 plus because it has 2 more protons than it does electrons, and it is now charged, so it's no longer a neutral atom, it's an ion. Now, conversely, if say you've got sulfur, and sulfur needs to lose 2 electrons, sulfur needs to gain 2 electrons to move to its closest noble gas configuration, which for it will be argon. So if it wants to move to the same configuration as argon, which is nice and stable, it needs to gain 2 electrons. And for it to gain 2 electrons, it's now become an ion, and it'll have a negative charge. In fact, its charge will be 2 minus. Its valency as a neutral atom is 2 negative or 2 minus, and that's because when it moves to that ion, that's what its charge will be. Sorry, its charge will be 2 negative because it has 2 more electrons than it does protons. And the valence is the same as the overall charge of the ion. So the valence of the neutral atom, as we see in the periodic table, is the same as the charge of the ion which is formed. Now, the main block groups tend to have the same valency all the way through. For example, everything in group 1 has a valency of 1 plus. Group 2 has a valency of 2 plus. Group 3, with the exception of boron, which is a bit different and weird, we get a 3 plus all the way down. Well then, whatever. In group 4, it sort of starts to mess around a bit towards the heavier end. And that's because the heavier end has a lot more electrons. So there's just more configurations that are possible. But group 5, we're on the 3 minuses pretty much. And that's because it gains 3 electrons to get to the 8. Group 6, it needs to gain 2 electrons because it's got 6 valence electrons, so that means it's a 2 minus. 7 is a 1 minus because they've got 7 electrons in the outer shell. Whereas then we get to group 8 and it's a 0 all the way down, and that's because they are all stable noble gases. So let's look at what a cation is, right? If an electron is donated from a neutral atom, so it becomes a positive ion. For example, here we've got magnesium. Magnesium has 2 electrons in the outer shell. So the magnesium atom loses its 2 electrons, its 2 valence shell electrons, and it becomes a magnesium ion, which then moves to its nearest stable noble gas formation, electron formation, or it gives it an octet in the outer shell. So it now has more protons as an ion than it does electrons, which means it has a positive net charge. This tends to happen in the metal ions because they usually have 3 or less electrons in the outer shell. And the reason this happens there is because it's just that little bit easier, right? Like it's easier to lose 3 than it is to gain 5. So ionic bonds form when an anion, which is a negative ion, and a cation are in close proximity to one another. And once they are, they electrostatically bond together, which neutralizes all of the charges around them. So let's talk about anions. Now, sometimes, to gain that stable outer shell, an atom will accept or take electrons from another atom. And this is how they get the same electron configuration as their nearest noble gas, or the octet on the outside. So more electrons than protons gives us a negative net charge, and this tends to form the non-metal atoms which have 5 or more valence shells. And there's a bit of toing and throwing in group 4. But if you've got 5 or more valence electrons, you will most likely form an anion, and you'll also accept 3 electrons from a metal or from a group of metals, whatever, and you'll become an anion. Now, ionic bonds form, as we said earlier, when an anion and a cation get too close to one another, and they will form an ionic bond. For example, we have magnesium, and it will bond to oxygen. And the way it does this is by transferring electrons from one to the other. Now we look at polyatomic ions. Polyatomic ions are all of these guys in here. Now, they are molecular ions or polyatomic ions. They are ions which are covalently bonded and tend to act as a single unit. This group here is the group of polyatomic ions that you as a student will need to remember. This is a much more complete set, but this subset here are the ones that you'll have to remember. I hope that made sense. If you have any questions, put them in the comments below and we'll get back to you as quick as we can. Don't forget to subscribe so you can keep up with everything we're putting out there. And yeah, thanks for watching. Bye now.